Once you know how to complete the square, it's not difficult to see. It's not trivial, but it's not difficult. It's moderate difficulty, seeing where the quadratic formula comes from. Let's just start out with this equation. Okay, well, we can rewrite this equation as 4 times x squared plus 6x minus 7 equals 0. Why do I do that? Well, I'm going to end up completing the square on 4x squared plus 24x. Okay, I complete the square. I need to add 9 to the x squared plus 6x. Now, as soon as I add 9, I've added something on this side. I haven't added it on this side, and I really can't add it on this side because on this side it's multiplied by that 4. But I just right there where I add it, I subtract it. So it's kind of there, and it kind of isn't, because it's kind of a 0. Anyhow, then I do the minus 7 equals 0. Okay? Then I write this as 4 times the quantity x plus 3 squared minus 9 minus 7 equals 0. And then I distribute the 4. 4 times the quantity x plus 3 squared minus 36 minus 7 equals 0. And 36 and 7 is 43, that's minus 43. I add it to both sides. I have 4 times x plus 3 quantity squared equals 43. So x plus 3 squared equals 43 over 4. It follows then that x plus 3 is plus or minus the square root of 43/4. Now that could be reduced to the square root of 43 over 2. I'm going to leave it this way right now. So that x equals what? Subtract 3 from both sides, negative 3 plus or minus the square root of 43 over 4. Then I can do some simplification and other things depending on the exact problem, but this will always work. Now I note that if this had been, instead of minus 7, let's say this had been plus 50, then instead of minus 7 here, I'd have had a plus 50. When I add it to the negative 36, I'd have had a plus 14, and that would have given me a negative 14 on this side. Then I had x plus 3 quantity squared equals a negative number, and no square can equal a negative number. I would conclude that I had no solution. Okay, well, this is an application of completing the square. I've solved this problem, this equation, by completing the square. Okay, well, in general, if I have the equation ax squared plus bx plus c equals 0, I can complete the square and solve it. I only have letters here, I don't have numbers, so I'm going to have to deal with some fractional expressions, but they're not going to have numbers in them. I'm just going to have a's and b's and c's. So what I do is I first factor out a, okay? And you can verify by the distributive. Well, if I multiply through by a here, I do get this, so this factoring works. Okay? Then I have a times x squared plus b over ax plus, what do I need to complete this? I need the square of half of this. I have to square half of what's in front of x. So I have to take b over 2a, my chalk let me down there, squared. And then I'd better subtract the square of b over 2a and complete my parentheses. So now I have everything that's in parentheses, because of course this minus this is just 0. which gives me a times x squared, a times x plus b over 2a quantity squared, because right here I've completed the square. And you can expand this, and you should expand this and see that it's equal to the underlined part here, but not this. So we have the minus b squared over b over 2a quantity squared. Better learn to be careful. Maybe too late in my case, but you learn it. Okay, so here we have it. So this is a times the quantity x plus b over 2a squared minus a times this quantity. I better write that out, because if I write out the result, you wonder where the a went. Okay? Yeah, I'm going to have to do this stuff. Running out of room here. I didn't need that second parenthesis. Get rid of it. Smooth out the smudge. Okay. Now, a times quantity b over 2a squared. This is b squared over 4a squared. Multiplied by a, I get b squared over 4a. That's plus c. That's equal to 0. So now I have a times the quantity x plus b over 2a squared equals, well, I subtract c and add b squared over 2a is going to give me b squared over 4a. B squared over 4a minus c. Okay? So, and I've always said, whenever you have denominators, multiply everything by the denominator. And I've had denominators ever since here, and I haven't done that yet. And I think maybe I don't want to do it yet, because this denominator is stuck inside the square and you can't just multiply it out. So I'm going to keep it there. Okay, so I'm going to now divide both sides by a. So I'm going to get x plus b over 2a quantity squared equals, okay, 1 over a times all of this. Everything here. Well, that's 1 over a times b squared over 4a is b squared over 4a squared. Then I'll have minus c over a. So that x plus b over 2a is equal to plus or minus this. So that x equals b over 2a, negative b over 2a, subtracting the b over 2a from both sides, plus or minus square root of b squared over 4a squared minus c over a. Now, still don't want to multiply through by denominators, because some denominators are inside of square roots and so forth. Kind of tempted to do that, but I'm just going to instead do a common denominator inside of here. Common denominator is going to be 4a squared. This term already has that denominator. And I multiply the numerator and denominator here by 4a, which is going to give me a 4a squared in the denominator here. So now I have b squared minus 4ac in the numerator. This is the common denominator, 4a squared. And then the square root of the numerator of the denominator is the square root of the numerator divided by the square root of the denominator. The square root of 4a squared is 2a. Look there, I've got a denominator of 2a, common denominator, and I get b plus or minus the square root of b squared minus 4ac all divided by 2a. Since I'm out of board, it's a good thing I'm done. There's the quadratic formula. Okay? X equals this, equals this, equals this, equals this, so that x equals this. All comes out from completing the square. Now, because of the symbols, there are more steps here than there were here. But once we've done this, we don't need to do all this. We know it's always going to work out, so that all I've got to do is figure out what A, B, and C are and plug them in to this formula.